Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Danish Haziq bin Zulkifli. Number metric is 09DEP20F1018. Okay, now I want to present about diode. Okay, first of all, diode is a semiconductor device which has a single p-n junction that allows electric current to flow through it in only one direction, that is from anode to cathode. Okay, now we go to physical structure of a diode. Okay, I want to describe physical structure of the diode. Okay, the diode is a two-layer, two-terminal semiconductor device. When N-type and P-type semiconductor material are joined together, this forms a p-n junction which is referred to as a diode. The semiconductor diode operates to allow current to flow through it in one direction but not the other. Okay, this is a anode and cathode. Okay, this is a picture of anode and cathode. Okay, now I want to describe schematic diagram of a diode that is forward bias and reverse bias. Okay, this is a schematic diagram of a forward bias and reverse bias. Okay, there are two different types of diode basing, namely forward bias and reverse bias. Okay, the diode also acts like a switch. If the anode terminal of the diode is positive, with respect to the cathode terminal, the diode is said to be forward biased, as seen in figure 2.5a. In this condition, the diode is equivalent to a closed switch. On the other hand, if the anode terminal of the diode is negative with respect to the cathode, the diode is said to be reverse biased, as seen in figure 2.5b. In this condition, the diode is equivalent to an open switch. Okay, this is a picture forward bias and reverse bias current flows, and reverse bias is no current. Okay, figure 2.6 shows a battery and resistor connected in series with a semiconductor diode. If the negative battery terminal is connected to the cathode and the positive terminal is connected to the anode, the diode is in forward bias condition, and the diode thus acts as a closed switch. Current therefore flows through the diode as shown in figure 2.6a, provided a minimum voltage called the forward breakover voltage is applied. The resistor protects the diode from destruction due to excessive current, which would result if the diode was connected directly to the battery. The minimum voltage is dependent on the type of material used. The minimum voltage varies from 0.3 volt to 1 volt. For germanium diodes, the forward breakover voltage is about 0.3 volt, and for silicon, it is approximately 0.7 volt. If the positive battery terminal is connected to the cathode and the negative terminal is connected to the anode, current does not flow stop the diode, and this condition is called reverse bias. As shown in figure 2.6b, no current flows through the diode when it is reverse bias unless the voltage is increased until a certain critical voltage is reached. Okay, this is my presentation about a diode. Okay, thank you for watching.